Let us learn about diagonal theorems related to parallelograms. Till now, we have learned about the theorems related to the sides of a parallelogram and the angles of a parallelogram. Now, we learn about theorems related to the diagonals. The first theorem states that the diagonals of a parallelogram bisect each other. That is, OA is equals to OC, OA is equals to OC, and OD is equals to OB. OA is equals to OC and OD is equals to OB. And we are also given that ABCD is a parallelogram. So to prove is this. Now if we look at triangle AOB and triangle COD, then I can say that angle AOB should be equal to angle COD because these are the pair of vertically opposite angles. Therefore, angle AOB is equals to angle COD because these are vertically opposite angles. And since ABCD is a parallelogram, so AB should be parallel to CD. So angle CDO must be equal to angle ABO because these are a pair of alternate interior angles. Therefore, angle ABO is equals to angle CDO, alternate interior angles. And also, opposite sides of a parallelogram are equal. So I can say that AB is equals to CD because of side theorems of a parallelogram. Therefore, I can say that triangle AOB is congruent to triangle COD by AAS congruency rule. Now, since these two triangles are congruent, therefore corresponding sides and angles must also be equal. Therefore, I can say that OA is equals to OC and OD is equals to OB. Now theorem 2. Theorem 2 is again a reverse of theorem 1. It states that if diagonals of a quadrilateral bisect each other, then it is a parallelogram. Here it is given that OA is equals to OC and OD is equals to OB, and we need to prove that ABCD is a parallelogram. If we look at triangle AOB and triangle COD, I can say that OA is equals to OC. OA is equals to OC because it's given. Also, OD is equals to OB. It is again given. And angle AOB is equals to angle COD because these are a pair of vertically opposite angles. So by Sas Congruence Rule, I can say that triangle AOB is congruent to triangle COD by Sas rule. And since the corresponding angles will now be equal, therefore angle 1, that is this angle, angle 2. Angle 1 is equals to angle 2. And since these two are alternate interior angles, so I can say that AB is parallel to CD. Similarly, angle 3 is equal to angle 4. So I can say that AD is parallel to BC. Now since pair of opposite sides are equal, so we can say that ABCD is a parallelogram. Therefore, we have proved that if diagonals of a quadrilateral bisect each other, then it is a parallelogram.